Now, we discuss some special problems based on the topic conditional probability. Here, we discuss some a problem, some problem that is some different way of finding the conditional probability. Our first question is, consider the experiment of tossing a coin. If the coin shows head, toss it again. If it shows tail, then throw a die. Find the conditional probability of the event that die shows a number greater than 4, given that there is at least one tail. In such cases, first of all, we form the sample space. Okay. First of all, we tossing a coin. If the coin shows head, we toss it again. That means we get head. Again, we toss the coin. If we toss the coin, we toss it, but we get head or tail. That is H, or we get element head or head tail. And if show tail critical, coin toss is head critical, coin again toss here, we get possible elements are head or head tail. If you get a tail, then throw a die. For tail critical, suppose die thrown, possible outcomes are 1 to 6. That is, we get the elements are T1, T2, T3, T4, T5 and T6. And therefore, the possible elements of the sample space is HH, HT, T1, T2, T3, T4, T5, T6. Because when the coin toss, if you get a head, again coin toss, and if you get a tail, then a die is thrown. Possible outcomes are there. Here the total element is not 1, 2, 3, 4, 5, 6, 7, 8. Is not correct. Our sample space contained there. Suppose when a coin is tossed two times, we get 4 elements, and coin tossing and die throwing, we get 12 elements. There exists only 6 plus 8, only 8 elements. It's not the element of the sample space actually. But in the case, we direct number of elements is equal to 8 is not correct. Because we have random experiment sample space create. Okay. Now, our first event, A be the event that find the probability that event that die shows a number greater than 4. A be the event that probability that die shows a number greater than 4. Die shows a number greater than 4, and B be the event there is at least one tail. At least one tail. We consider the two events. First event is die shows a number greater than 4, and B be the event that at least one tail. And therefore, the elements of A, die shows number greater than 4. Therefore, the elements are T5 and T6. And thus, event B contains the elements are at least one tail, mean one tail or two tail. Possible elements are HT, which contain T, then T1, T2, T3, T4, T5 and T6. The possible outcomes are HT, T1, T2, T3, T4, T5 and T6. Here A intersection B is equal to T5 comma T6. Now we use the formula P of A given B is equal to, using the formula conditional probability formula is P of A intersection B divided by P of B. P of A intersection B divided by P of B. That's it. Now we find the probability of these events. Actually, in these cases, we find the probability of each element. First of all, we find the probability of A. That means the element T5, the probability of the element probability of getting the element T is 1 by 2. You know, when a coin is tossed, probability getting tail is 1 by 2 into probability getting 5. You know what is the probability getting 5? When a die is thrown, getting 5, probability getting 5, answer is 1 by 6. Therefore, probability getting the element T5, answer is 1 by 12. And probability getting T6 also, probability getting T6 is also, probability is 1 by 12. Okay, actually probability, suppose a coin is tossed, okay, A coin is tossed 2 times. You know the possible outcomes are head head, head tail, tail head, and tail. Our question is, what is the probability of getting head? Exactly one head. You know the event for getting one head is HT and TH. Actually, you know. And the probability this event is, the event A contains 2 elements divided by total outcome is 4 is equal to answer is 1/2. So one method. In second method, probability getting A എന്ന് പറയുമ്പോൾ first we find the probability of getting H. You know what is the probability of H? When a coin is tossed a single time, probability getting head is 1/2 and probability getting tail is 1/2. That is 1/2 into 1/2 plus second element TH. Here probability getting T is 1/2. Probability getting head is also 1/2. That is equal to 1/4 plus 1/4 is equal to, we get answer 2/4 is equal to again 1/2. These are the two methods for finding the probability of an event. Direct കണ്ടുപിടിക്കാം. ഇപ്പോൾ സപ്പോസ് സാമ്പിൾ സ്പേസിനകത്ത് ഒരു ഒറ്റ എക്സ്പെരിമെൻറ്റ് കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ നമുക്ക് ഡയറക്റ്റ് ആയിട്ട് നമ്പർ ഓഫ് എലമെൻറ്റ്സ് ഓഫ് ദാറ്റ് ഡിവൈഡഡ് ബൈ നമ്പർ ഓഫ് എലമെൻറ്റ്സ് ഓഫ് ദി സാമ്പിൾ സ്പേസ് എഴുതി നമുക്ക് ഡയറക്റ്റ് ആയിട്ട് കണ്ടുപിടിക്കാം. അപ്പോൾ ഒരു സാമ്പിൾ സ്പേസിനകത്ത് 2 എക്സ്പെരിമെൻറ്റ് കമ്പൈൻ ചെയ്താണ് നിങ്ങൾ ഫോം ചെയ്യുന്നതെങ്കിൽ ഇൻഡിവിജ്വലായിട്ട് എലമെൻറ്റ് വൈസ് നിങ്ങൾ പ്രോബിലിറ്റി കണ്ടുപിടിച്ച് ആഡ് ചെയ്തെടുക്കുക. സെയിം സപ്പോസ് you take another experiment, suppose a coin toss 3 times. You know the possible outcomes are head head head, H H T, H T H, T H H, H T T, T H T, T T H, and T T T. Already you know. Suppose we find the probability getting exactly 2 head. You know the possible elements are H H T, H T H, and T H H. You already know the first method. We find the probability that event is, you know, contain 3 elements divided by total outcome answer 3/8. That's all. And second method is, you know, what is the probability getting H is 1/2 because a coin tossed a single time, probability getting head is 1/2. Again head probability is 1/2. Again tail probability is again 1/2 plus here also 1/2 into 1/2 into 1/2 and third is also 1/2 into 1/2 into 1/2 and finally we get answer 3 divided by 8. It's the second method. These are easy because the experiment contain only one experiment, that is for the sample space another coin 3 times എന്നുള്ള എക്സ്പെരിമെൻറ്റ് മാത്രമേ ഉള്ളൂ. പക്ഷേ ഈ കേസിൽ നമ്മുടെ ഈ എക്സ്പെരിമെൻറ്റിൽ നമുക്ക് ഇവിടെ സ്പെഷ്യൽ പ്രോബ്ലംസ് ആയിട്ട് തന്നിരിക്കുന്ന എക്സ്പെരിമെൻറ്റിനകത്ത് നമ്മുടെ കോയിൻ ടോസിങ് മാത്രമല്ല, ഇവിടെ നമുക്ക് ആ സ്ഥാനത്ത് നമുക്ക് ഒരു ഡൈ കൂടി ത്രോൺ ചെയ്യുന്നുണ്ട്. സോ ദർ ഇസ് 2 experiment. Okay. Coin is tossed, if you get a head, again coin is tossed, if you get a tail, again die is thrown. Okay, so probability getting A means, first of all we find the probability getting tail. You know the probability getting tail is already, you know, 1/2. Probability getting 5, you know, in a die is thrown, if you get what is the probability getting 5 is 1/6 plus then second element tail probability is 1/2 and 6 probability is 1/6 is equal to 2/12 plus 2 divided by 12, that is 1/12 plus 1/12, that's equal to 1/6. That's all. Then probability getting B. What is the probability getting B? You know probability getting head is 1/2. Again probability getting tail is 1/2 plus here also probability getting tail is 1/2 into 1/2 into probability getting 1 is 1/6 plus T2 1/2 into 1/6 plus T3 1/2 into 1/6, again T4 1/2 into 1/6, T5 and T6 1/2 into 1/6, also last 1/2 into 1/6. That means 1/4 plus these are 6 elements, that is 6, 1, 2, 3, 4, 5, 6, that is 6 divided by 12 is equal to 3 divided by 12 plus 6/12 is equal to, we get answer 9/12. And we can simplify. And what is P of A intersection B? P of A intersection B is equal to, we get answer T5 and T6. T5 and T6 mean same A probability, that is 2 divided by 12. And therefore using first equation P P of A given B is equal to, answer is P of A intersection B is 2 divided by 12 divided by what is P of B? 9 by 12. Here 12 12 cancel and finally we get answer 2 divided by 9. So for the required probability, answer is 2 divided by 9. Okay, 2 divided by 9. This is something different types of problem. Now we will discuss one more question similar to this type of special case. Consider the experiment in which a coin is tossed and if the coin shows head, it is tossed again. But if it shows tail, then a die is tossed. If 8 possible outcomes are equally likely, find the probability that die shows a number greater than 4, given that the first throw of a coin results in a tail. Our sample space contains elements. A coin is tossed, and if the coin shows head, it is tossed again, similar to last problem, that is head or head, tail. If it shows tail, then a die is tossed. Therefore, we get answer T1, T2, T3, T4, T5 and T6. There exists two random experiments. Combine the form chain. But two experiments are experiments and process. Okay, we get 8 possible outcome. Okay, now we find the probability of each element. That is, first of all, we consider first we find A. Find the probability that die shows a number greater than 4. Die shows a number greater than 4. And B be the event that first throw of a coin to result in a tail. First throw result in a tail. Okay. Then what is A? What are the elements of A? Number greater than 4. Elements are T5, T6. Then what is B? First throw resulted in a 5 means T1, T2, T3, T4, T5 and T6. Okay, now A intersection B is equal to, we get answer T5 and T6. Now the probability of A, you know the probability getting tail is 1 by 2 and probability getting 5 is 1 by 6. Plus second element is also 1 by 2 into 1 by 6 is equal to 2 divided by 12. When I simplify, but common denominator cancel 2 by 12. Now P of B, you know T1 probability is 1 by 2 into 1 by 6, that is 1 by 12 plus 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 1 by 12. There is a 6th element, that is equal to 6 divided by 12. Now P of A intersection B is equal to, there is 2 elements, that is 1 by 12 plus 1 by 12 is equal to, again we get answer 2 divided by 12. Now using the definition P of A given B, we find the probability of A given B, because we find the probability that die shows a number greater than 4 given that the first throw result in of A, that is B, that is P of A given B. Definition, we get P of A intersection B divided by P of B. You know P of A intersection B is 2 divided by 12 divided by what is P of B is 6 by 12. That is equal to, we get answer 2 by 6 is equal to 1 by 3. That's all. Okay. First of all, we understand the concept how to find the probability of this event, because there exists two experiments. You can two experiments to combine the form. Single experiment is no problem. Total number of elements and S element consider division. But coin tossing and die throwing experiment total number of elements S number of elements. So individual item probability contribute sum. That's a method for finding this type of problems. Okay, we'll do one more question similar to this type. Consider the experiment of throwing a die. If a multiple of 3 comes up, a die is thrown again. A die is thrown again. And if any other number comes, a coin is tossed. And if any other number comes, a coin is tossed. Find the conditional probability that the coin shows a tail, given that at least one die shows 3. Find the conditional probability that the coin shows a tail given that at least one die shows a 3. First of all, we form the sample space. When a die is thrown, if a multiple of 3 comes up, a die is thrown again. That means if we get 3, again throw, we get 3, 1, possible outcome 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And any other number comes, a coin toss. Suppose if we get 1, coin toss, we get answer 1H. 1 tail. Possible outcome 1H and 1 tail. And 2H, 2 tail. 3 is a multiple, 3 വന്നു കഴിഞ്ഞാൽ നമുക്ക് die thrown ചെയ്യാം. Again 4H, 4 tail. 5H and 5 tail. That's all. It's a sample space. Now A be the event. We find the probability of the A be the event that coin shows tail. Coin shows tail. And B be the event. At least one die shows 3. At least one die shows 3. And therefore the elements of the event A are coin shows tail are 1T, 2T, 4T, and 5T. Then what is B? B be the element. At least one die shows 3. That means 3 contains element. 3 രണ്ട് element 3 വരാം, ഒറ്റ element 3. That is 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, and 6, 3. Okay. Then here A intersection B, there is no element is common and therefore 5 is the answer. Now you know what is the probability of A. P of A means 1 by 12 plus 1 by 12 because the element of getting 2 is 1 by 6 and 1 by 2. Then 1 by 12 plus 1 by 12 because 5 2 means 5 element of the probability getting 5 is 1 by 6 and probability getting tail is 1 by 2. That is equal to we get answer 4 divided by 12. Now probability of B for getting 3 is 1 by 6 and probability getting 1 is also 1 by 6. 1 by 6 into 1 by 6, 1 by 36 plus 1 by 36 plus there is 3, 6, 7 element, that is 1 by 36 plus 1 by 36 plus 1 by 36 plus 1 by 36, 3 plus 1 by 36 is equal to we get answer 7 divided by 36. And probability of A intersection B, you know answer is 0 because null set. And therefore P of A given B using formula P of A intersection B divided by P of B. You know P of A intersection B is 0 divided by 7 divided by 36 and answer becomes 0. Therefore the answer is the probability getting the event that the coin shows a tail given at least one die shows a 3, answer becomes 0. That's all. Next video we will discuss what is independent events and the problem based on that topic. That's bye.